And we're live. Hi, welcome to the .NET Community Standup, the Tooling Edition. I'm one of the hosts, Kendra Havens, a program manager at Microsoft on the .NET team. With me is my co-host, Jordan.
Hey, I'm a program manager on the Visual Studio for Mac IDE. Howdy, everybody.
Hey, our guest today, wait, does that look right? There we go, is Jonathon Marolf.
It's me. I'm not a PM. I'm a developer. I'm here today. Hi everybody.
The best kind. Yay. So today we're going to talk about John's fabulously popular blog post on finding latent bugs in your code and .NET 5 analyzers. So first we can probably talk about it. I can share the link in chat. And let me make sure I got the right thing in my clipboard. Ooh. So you guys can read up on it if you haven't before. It is very good. John says we look and sound good. Thank you, John. I also feel like I look good. Okay. So, this is super impactful work because we're finding and giving more information on errors and warnings and all this stuff in the frameworks that we've never been able to give and how we use it.
Yeah, this has been, I've been working on the Roslyn team, which is the code name we use for the managed compilers, so C# and the Visual Basic compiler. I've been working on that for a long time, pretty much since I've joined Microsoft. And ever since we started that project, we wanted the ability to add more intelligence to .NET in terms of the way the framework worked, in terms of the way APIs worked, and to sort of bring that to everyone. And it's very exciting to finally say we're doing that now with .NET 5, where you get a smarter platform overall.
Yeah, definitely. So should we go through, I guess, this is the first part of the blog post, and then we can hop into some code? I guess I just want to explain analysis levels, and you have your really nice table that kind of made it concrete. I know when we were looking at drafts, I was like, I need a visual.
Tables help a lot, I learned writing this blog post. But yeah, we can talk about that. The new concept we're introducing in .NET 5 is called analysis level. And as a .NET developer, let me just start off in saying you don't have to care about this. There's a default that's selected for you. The default is the latest. And so when you go to .NET 5, what's going to happen is we will have the compiler give you new warnings about various code patterns that we know are likely wrong. And we'll show you what some of those are as an example later. But so that just means when you move to .NET 5 from .NET Core 3.1, which we know everyone's on, when you move there, you'll just get better analysis warnings automatically. If for some reason you sit there and you say, this is a blocker for me, I need to actually sort of deal with these warnings later, you can change the analysis level from 5, which is the default for .NET 5. I wanted those numbers to match. Don't know why. You can change it to 4, which is what we set previously for all the sort of previous versions. So say analysis level to 4 gives you the old behavior. And then if you're also, let's say you're on .NET Core app 3.1 on a new compiler, like the .NET 5 SDK, but you're targeting 3.1, and you want to get the better warnings about different code patterns, you can set analysis level to 5 or latest in that project, and then you'll get them even though you're targeting a different framework. So we default you to the latest for the new frameworks, but analysis level allows you to have control over what makes most sense for your individual projects. And so but again, you don't have to care about it. But if you want that level of control, which makes sense for some very large projects and small ones too, you have it now. And that's, I think, the main points I would like to get across.
All right. So I'm going to step through some of the basic scenarios. So let's say I have a .NET 3.1 app, but can I use analysis level 5?
Yeah. So
but it wouldn't do anything?
Oh, no, it works just fine. This is not, I mean, a lot of times in our messaging, for good reason, we say, well, it's all tied to a version of .NET Framework, but this is just a compiler feature. It doesn't care what target framework you're using. It just cares what compiler you're using. So you'd have to have a new .NET SDK. So you'd have to have the .NET 5 SDK, because the feature comes with the compiler in that SDK. But as long as you have that, you can use this anywhere. You can use it in .NET Standard. And before people ask, it is possible to do it in .NET Framework projects, though it's a little more complicated. But if you have the SDK style projects, basically, if that's what you're using, the simplified project format today, then once you have the new SDK, you get this feature.
Okay. So I'm targeting, let's say, I start a brand new project. I'm targeting Net 5 in my little target framework field. And I've set, and I haven't set my analysis level. So that's immediately going to, by default, be at the highest level, which is 5, because versions correlate, because we thought ahead. So I'm going to get the maximum amount, I guess, of warnings, errors, all of those little analyzers that are now newly added to our .NET 5 libraries with the latest, I guess, targets that I could possibly be checking.
Yeah, I mean, if you cut to my screen here real quick, I did add some information in the project property pages for people using Visual Studio. I know that's not everyone, but so we actually, under code analysis level here, we will actually list what your current analysis level is. And so you can set it to none to say turn this feature off if you want. You can set it to latest, which is the default. And then we also have preview, which will mean that you are opting into potentially experimental warnings from the compiler that we intend to ship, let's say in .NET 6, but if you want to try them early, you can. And so that is, I think, the easiest way for Visual Studio to say, what is my analysis level today? You can go and just look at the project property pages, and that will tell you. If you want to modify that, you can. Yeah, that's, I think.
Yeah. You just brought up that we'll have future versions, I guess. So .NET 6 will have an analysis level 6 going forward?
That is the plan. I work with emos, so you can never bet on whether numbers will make sense or stay the same, or who knows, right? But yes, the plan is there'll be a .NET 6, and in .NET 6 we will have analysis level 6. So hopefully that can stay fairly easy to remember, of like, well, I want the sort of compiler analysis that I got with .NET 5. Okay, I'm going to change analysis level 5. I want .NET 6. Okay, level 6. Hopefully, as we move, we can keep that consistent. And it can hopefully be fairly easy to map. Yeah.
Cool. So why don't you show us some of these new .NET 5 analyzers that people will be, I guess, seeing for the first time?
Absolutely. I'd be happy to. This is one that everyone on the Roslyn team is super excited about. It was really unfortunate I demoed this during, the times we live in where we weren't all in person, so I couldn't hear people screaming with applause. But this is one we've wanted for a long time. And it's something that I think when you first describe to someone, they're like, why can't you just do this? But there's reasons. So we have a date time, which if you're unfamiliar, this is a struct type. So that means it can't be null. But we're comparing it to null here, which is honestly nonsensical. And so back in the day, we used to not warn for this. We would say, this code does nothing, but we didn't tell you. Now we'll actually say, hey, this expression is always false or always true. There's lots of weird cases that we encountered that, like, going way back to when Roslyn was first project, where as we tried to move people up, we originally had this in the compiler, and it would break because people were doing stuff like this where they were comparing types to, like, structs like this. They're basically wanted to know if this was like a nullable of T type or something. And, this was a blocker because people would get a lot of errors in this code. We and Roslyn have a lot of errors like this in our code. And the only reason we don't is because we have this warning to let us know This sort of thing happens all the time, especially like in LINQ or something where you have variable X and it's not obvious to you that this is a struct or a class. There's just a lot of people that will unintentionally compare structs to null, and they don't have to. Now the compiler tell you like, hey, this code doesn't actually do anything. Whereas before you had to live it. And yeah, I kind of spoiled it here, but we also will warn you now if you're trying to do is on static classes. So in C# you can declare a static class, which means, hey, you're not allowed to do a lot of things with this class. You're not allowed to inherit it, not allowed to create a new object of it, for example. And so we just know like, well, O can't be Fizz because Fizz is a static class. So like, that's just, since this is an instance and Fizz isn't allowed to have instances, this is nonsensical. And so we can tell you that like, hey, if you're planning to do something with this answer, whatever it is, it's not going to be helpful.
And what does the warning actually say? Does it say like replace or phrase will always be true?
The second operand of an is or as operator may not be statically typed. Static type Fizz. So we have a special warning for this. I'll go ahead and like comment these out so I don't see a giant bunch of warnings in the error list.
Sure. Actually, that kind of brings us to the next my next question. People don't want to see a ton of warnings in their error list. So I think at the very beginning with the date time and struct is nullable kind of comparison, you mentioned that this is so obvious, that we shouldn't be doing this. Why wouldn't we just have this as a warning all the time?
Well, so the answer is a long-standing problem for the compiler team is the feature warn as error exists, which we're getting a little bit into, I think how people think about their code and how they want to manage it. And that's a very personal thing. So everyone has preferences. So a lot of people will set warnings as errors, which means if there's a warning, fail my build, which I can totally agree with, because I think there's lots of situations where, hey, if we don't do that, warnings are just going to accumulate over time, because when the chips are down and you've got to get a feature in, most people aren't going to have the discipline to go and ensure their code compiles without warnings. And so if you make an error, you say, no, we're just making a statement. You can't do that. You have to fix all your warnings. And so that to a lot of people makes a lot of sense. But then now once you add new warnings, now you're breaking people's code. So someone takes a new compiler update, and now they can't just take that and start, let's say, using new language features. Now they have to fix any new warnings immediately in their code, and they have no choice, right? They have no capability to configure that. So the concern with this feature was always, well, if we add new warnings, that's sort of breaking people. We need to give them the ability to, worst case scenario, just turn those new warnings off if they have to, and potentially configure them on a case-by-case basis. So that's, again, another reason why analysis level exists, is so that if you need to bulk configure these, you can. But like everything in Visual Studio or in just .NET Tooling, you can suppress issues in source. You can do this pragma suppression thing for an individual case, or do the suppression file, or add attributes and various things. So you can do that also from the error list. If there's like a group of them, you can go and say suppress, right? And or just turn off that particular rule. You can type no warn, whatever. So that was, I think, one of the reasons we didn't do this feature in the past and felt we had to figure this out, is how do users have all the tools they need to configure it so that whatever their project does, we don't pigeonhole them and force them into a corner. Because there's millions and millions of lines of code written in C#, and being too opinionated can lead to a very difficult situation for a lot of projects. You don't want to hear like the Australian government's like, we can't do anything today because you broke us because your new warning. So
that can be really impactful. So since we've almost had our hands tied up till now because we didn't have like a way to successfully introduce these without breaking people, I guess. So we've just been storing up all of these, I guess, framework specific patterns and things we wish we could tell people for a long time, and now we finally can.
Yeah, as Dustin Campbell first mentioned when I showed this, I was like, finally we can tell people they're wrong, which is a little facetious. That's not, I think, the intention here. The hope is, again, we can give you a smarter platform that you get to decide what matters to you. There's other analysis we didn't include yet. We're being a little conservative, but like, yeah, hopefully someday you could say, hey, this project is very performance sensitive. We care a lot about how this code performs. And so we could do initial analysis like, hey, you're doing a lot of things that are not going to make this code fast. Here's a faster alternative because we know you've asked for that and you care about it. And so that's really the goal, is to, instead of be dogmatic and tell you you're wrong, is to give you the tools to make your code as good as it can by default, just built into the compiler without needing a bunch of additional tools.
Right. Like when you're in the mood for that dogmatic kind of feedback, you can go and get it.
Or maybe that's just the way you are. There's
never.
nothing wrong with that.
Yeah.
You're just like, I want to be punished, and that's fine. Then you can, be as extreme as you want to be.
Cool. So did you have a couple more you wanted to show us?
I just want to show this one because it has a special place in my heart. This was the first analyzer I ever wrote when I was on the team. And the code fix for it I also wrote because it is the simplest one possible, is just remove this statement here. A lot of these we have are a lot of these are analyzers that we wrote that sort of come from a lot of the design from FXCOP. So if you're familiar with FXCOP as a 2008 technology that was shipped, a lot of those ideas we're now moving forward and putting again into the compiler layer here. But so this is a thing that I think everyone learning .NET immediately thinks about but doesn't realize is wrong, which is, as a kid, I learned to throw the ball and catch the ball. And so if I'm throwing an exception and I catch the exception, it makes sense that I would throw that exception back. This look of disapproval face is obviously because we're catching like all exceptions, which is a little scary thing to do. But this is actually the wrong thing to do in .NET. If you throw an exception object that you've caught, you will change the stack frames, which will make it very difficult to diagnose what actually happened to cause this exception. And so the correct thing to do is to actually just type a naked throw keyword to say that that's what you intend here. And very minor thing. Most people who are veteran C# programmers know this, but again, the whole goal is, well, if you're new to C#, we would like you to sort of, the defaults that the compiler and the language tell you are, useful and correct. And we have more examples for complicated stuff the framework is doing, if you want to go through those, but we may be out of time.
Oh, well, I mean, what else do we want to talk about is my interest. I did have one question. It was, so all of these new .NET 5 analyzers are taking advantage of analysis levels to kind of roll out verbosity when people are ready for them and everything. And we'll have like progressive levels as they go and everything. Can third-party analyzer authors take advantage of analysis levels yet?
That's a good question. Let's see. The answer is kinda. Let's see. So we have some pretty advanced capabilities to configure analyzers now. So like most things, analyzers that are shipped as NuGet packages come with props and targets files that you can generate for them. And so we now have a new capability where you can specify, hey, these are the MS build things. These are like the settings that are in my project file that I need to know about. And so you can set in your analyzer package, hey, compiler, pass this data to me. And so as an analyzer, you get that as a settings object. We give you like a dictionary. So you can, if you want, to say, hey, I want to know what the analysis level is to decide if I'm going to be active or not. You can do that in your analyzer. But that's just because you can get any MS build property now in .NET 5, where if you're an analyzer author, you could say, I want to know what the target framework is. And a lot of the analyzers that we're putting into the .NET 5 SDK that the framework team or the runtime team wrote use this capability to say, oh, you're on one of the most important ones is we now do analysis of like, hey, you're using an API and you said you're targeting, let's say, Mac, and we actually know that that API won't work on Mac, so we'll warn you about it, right? And to do that, the analyzer has to know what your project is targeting, which is not a thing the compiler knows, but is a thing that the project file talks about. So in a roundabout way, yes, it is possible to write analyzers that depend on analysis level because we do that, and everything we do is part of the public API that Roslyn ships. And so if someone wanted to do that, they could.
Yeah. So we got some positive chats in here. So try catch is very common use case, and knowing about throw and reasons why, why you, I guess, shouldn't pass in the generic exception is pretty useful. Pretty cool.
The only other one I wanted to show off is just because I think this is, again, actually demonstrating what I was talking about of the framework team being able to design and give us new APIs that they previously wouldn't due to dangers. There's this memory manager type. It's very specialized. I don't think most people wouldn't use it, but it's basically for defining your own span-based constructs. So if you're Unity or some high-performance program that really needs to manage your memory very exactly, you can derive your own custom memory manager, right? But if you for some reason implement one of these finalizers to the class, it's actually unclear what that will do to the runtime, and it may actually destabilize the runtime, cause your program to crash. So now we can actually warn you, this is a thing you're not allowed to do because we have no way to reason about what happens with the finalizer with this sort of unmanaged sort of type thing. And so previously the runtime team have been very I don't know if we can ship this. There's a lot of scary stuff about putting this type out, and they're oh, well, at least we can warn people of hey, if this is, this is a warning, so maybe you're doing this for debugging or something, and that's okay, but your production code should ideally not have a finalizer because that can really mess with what the runtime's expectations about how memory is going to work are. And we hope to see more of this, right? In .NET 5, most of these warnings are for very low level sort of span-like things. But we hope to have that expand. There's lots of types that are internal that if you're a inhabitant of the GitHub.NET runtime repo, people have been asking for it. Now it's oh, we could maybe give them the stack-based string builder or something, because even though that thing is really terrifying to use correctly, it is a major performance win. But we'll see. We'll see where we go from here.
Yeah, there's been... Oh, go ahead.
Angles. Oh, sorry about that. I was gonna say I love that there's both angles with these analyzers of those helping users fall into good patterns that aren't immediately obviously. You just kind of fall into the okay, that's a bad idea with just rethrowing the exception. And then there's that also extreme that if you're doing some stuff that is a bit advanced, it also saves you from doing some really bad things like preventing memory from being freed. So that's I love those kinds of things being in there by default myself. So
yeah, this other one's really cute, which is again a weird small API task completion source, which you'd think what's wrong with this. It turns out there's two different enums in the framework. One is task continuation options, and the other is task creation options. And this one actually accepts task creation options, but since it has a constructor that accepts an object, it will let you pass in just any old enum effectively. So you're allowed to do this, but this is just accepting. It's too small. Look at this is accepting an object, and so this will just do nothing. This option is not respected. And so we can finally warn you hey, emo screwed up. This API is kind of confusing, that it's task continuation options and task creation options. They both have sort of the same members. And we think you probably meant this. So that's, which again is a minor thing. How many people encounter this? I don't know. Hopefully not too many. But But now at least like, yeah, stuff like this, or we can say, hey, we even made maybe a unfortunate oversight in an API. We can now hopefully be smarter and let people, use things effectively. And yeah, similarly, like you're saying, be able to, for advanced cases where I'm using externs, say like, hey, this doesn't make sense. Like, don't use out, just use like the actual C# out keyword, which we know will work here because the out attribute doesn't actually do anything, or doesn't do what you want. But yeah.
Oh, nice.
Nice. Yeah, super cool. Oh, let's see. Sorry, I was in chat. I like it's very much like Clippy. You should try. You're trying to do too much. Are you sure you shouldn't do this instead? Very, very much what we're going for.
Yeah, all Microsoft projects trend towards Clippy at some point. And I don't know. I think everyone has some affection for Clippy. I'd still say it's just a matter of how useful actually are the suggestions.
Yeah. Yeah, definitely.
Now my mind's tangenting to wondering how many people no longer know the glory of Clippy, because
it is a dated reference.
Well, you've got to be. I remember in middle school thinking I was a real cool guy because I changed the default character from Clippy to, I think you could have it be like a dog or like Einstein or something. The other one was like just the Earth, and I was like, yeah, I'm even more unique. I'm an even more unique snowflake because I've got like Einstein suggesting stuff to me instead, which felt pretty cool.
Yeah. Let's see. Did you go over how you might get this in .NET Framework? I think you said it was possible. Do you want to share that right now, or are we going to look for more documentation later in the future? All good options.
Yeah, I'm sorry, I'm not looking at the chat if people are asking about that. But yeah, my general advice is, well, one, just know I'm not really testing that scenario. So if you encounter bugs, feel free to file them, but that's not something that like was the mainline thing here. I'm not trying to think to block it working, but I'm also not like doing a lot of testing to verify it works perfectly. I would generally say, if you look, this is like the new SDK style, what we call it, project. And regardless of what you're doing, I would, let me comment this. I would migrate your project to be that if possible. So you can do this in the new SDK style project where you say, hey, I'm targeting .NET Framework 4.8, and I want analysis level 5, so I'm overriding whatever that is, and this will work, right? Basically because this feature just comes from the SDK, so by definition, the SDK style project will have it. If you wanted to do this in an older style .NET Framework project, it's theoretically possible. Basically, the way you'd have to do that would be to go and add the analyzers that we add manually for you. So there are third-party NuGet packages that we will ship, and that's sort of the design is we'll still ship this Microsoft Code Analysis Net Analyzers package, so that if you're in some world where it's very difficult to get this SDK, you can just install this, and that'll get it. And then the compiler needs to be told to give analysis level 5 warnings, and so the way you would do that is set warning level to 5, which is a little confusing. That's what's happening. But that would be how you would do it on .NET Framework if you can't do the SDK style project and you're in the old project that has GUIDs and all sorts of things and very complicated. So that should
CS project.
The bad place, as we say.
The dark times.
But yeah, so it is possible. You can do it. I'm not doing a lot of testing on that scenario, but yeah, I'm not trying to block it either.
Okay.
But I would say it's definitely easier and simpler. And I think you will generally be happier if you're in an SDK style project. And I think, again, for a lot of other reasons, .NET 5 will give you some performance and just usability advantages over .NET Framework. But again, everyone's code. Some people are like, I've got millions of lines of code. I can't do it all in a day, John. I'm like, that's understandable. You can't.
Oh, yeah.
Rome wasn't programmed in a day. It wasn't even programmed at all. So,
yeah. Do you think we can kind of probably wind down on the questions here? Let us know in chat if you have any more for John. But I was just wondering, do you think this will change sort of what like default severities of analyzers that we check in? Because now we can say, oh yeah, we definitely want this to be like a warning or an error, but maybe they won't get it unless they're at a more progressed analysis level. So there's like a
there is a lot of internal discussion and meetings about sort of back compat and how this works with new warnings. Me and Manish have spent many mails and private Teams chats discussing this. Manish Vasani's sort of the lead, I would say, architect for analyzers at this point. He's written most of them. He's also literally written the book on them.
We should have him on the show.
Yeah, he's a great guy. So yeah, moving forward, we're basically bringing new warnings before a sort of compat council that like Stephen Tobe and a lot of other sort of .NET architect people are on, and sort of make the case. At least this is what I did for a lot of these, is make the case of like, this is why I think this is good. And then everyone sort of weighs in and like, yes, it is. No, it isn't. We kind of decide if it's okay to be turned on for the world. And then the plan is we'll add that to .NET SDK previews, or add that so if you log into the preview option here, you'll be able to see those and hopefully get feedback to see if we're actually right that those new warnings are there. So it's already come up multiple times between the compiler team and the runtime team of new stuff we want to add for .NET 6. But I'm trying to be a little conservative here for .NET 5 and say, well, let's just put a small set out because this is the first time we're doing this, and verify that all the right hooks and knobs for people to control what their code does are there. And
what's a small set? How many are actually in .NET 5?
I gave the complete list in the blog post, so I have my notes here from that. Let me just scroll
that was
up.
Like a dozen or so.
Yeah, 1, 2, 3, 4, 7, yeah, like about 12.
Okay.
So yeah, that's a dozen, which aren't. We could add
about the potential where we could
add hundreds. The question is like, well, is that useful? We're also toying with as well. While we're here, Manish would like me to. We're also toying with the ability to add code style enforcement to your build. So now you could make theoretically code style errors fail your build if that's what you wanted, or at least produce warnings. And in the past, you could get code style sort of stuff in Visual Studio or in VS for Mac or your IDE, but then there's no way to sort of enforce that easily on build. I worked with Joey on .NET Format to sort of a command line tool to do that. But now we would like to say, well, again, the compiler, if it's in the compiler, it's sort of a feature everyone gets for free. There shouldn't be too much work. So we are experimenting and hope by .NET 6 to have sort of the plan solidified for code style enforcement. So again, giving users the flexibility to say, for my project, these sort of things are errors or are warnings, and these things I don't care about, and I can specify that, and then know that like no matter who's developing, maybe it's an open source project, whatever tools they're using, they will get the right sort of warnings and errors and analysis to do the right things in my project automatically, and I don't have to spend time in code review telling them, oh, hey, this is the wrong style or whatever.
Yeah. I'm really curious, even though it's about a dozen, did we run this on Roslyn without having made any refactorings? And so even though there were only a dozen, how many instances of those actually caught and appeared?
You're really forcing me to reveal all the secrets here. So this 12, you may wonder, like some of these we had already implemented basically in the compiler.
And we implemented them because we knew that it was a problem. Yeah. So we might have already fixed a lot of cases.
Well, so we had a secret compiler switch we called strict mode that Neil Gafter wrote because he was so distressed that he couldn't do something about this. And so this was a flag that we basically turned on for Roslyn. I don't know. There's some people that blogged about it that tried to use it. But so some of these warnings, like especially the compare instructs to null and stuff, have been we've been using in our code base for a very long time. And so It's like, it's not like that we're great and that's why we're clean if you run these warrants. It's because, well, a lot of these we recognized and either wrote custom analyzers for the Roslyn code base to catch these cases or added them to the compiler directly under this strict flag. So we've
they
sort
were
of been
sort of internal just for us.
Yeah, we've sort of been cheating and living with a lot of these features for a long time, which is again why I had pretty high confidence that these were going to be the right things to ship, because we'd sort of been dogfooding them for years at this point.
Okay.
So today, if you were to turn this on, and you wouldn't see any errors in Roslyn, but that's not because we're incredible programmers. It's because we've been cheating and have had this
dogfooding them all along
running, for a very long time. But I recently turned this on because every code base that, I'll just say, don't feel bad, every code base I've turned this on, there's at least one instance of compare struct to null. Like I think there was the .NET SDK repo. I turned this on in one of their tests. They're comparing struct to null in like a link query, which is like, yep, everyone does that. It's just very hard to not with generics and just the world we live in, where we luckily don't have to think about types as much anymore, and just sort of types just kind of flow through your system with generics and var, and the way a lot of people, at least in the .NET org program.
Yeah. Well, cool. I don't know if anyone had any follow-up questions, but I think we can wrap up. Thank you so much for coming on and demoing, and that blog post is amazing, and thank you for all the work that you've done to check in this new level of features. It's been really cool.
Yeah, well, it's a lot, I think, to absorb in prose and probably on a stream. So, but if anyone has any suggestions or questions or concerns, feel free to at me on Twitter or GitHub or anywhere else. I'd like to know what is working or not working for you guys.
See if there's any last minute comments coming in. I just noticed the comments tab a little bit ago, so I'm glad you were on top of it, Kendra.
Oh, sure. Sorry, I think I'll end the broadcast then. Thanks all for tuning in.
Cool. Thanks again, John. See you later, Kendra.
Bye.